Thank you so much, Stephanie, for introducing me and getting my name right. Yeah, it's true that I salsa dance. It will take me just a minute to set up my computer. I also just learned that I only have 20 minutes for the talk and not 30, as I thought. So wish me luck. Let's see, do we get any output on the screen? Do we? Whenever you say something, just clap. Just one person. You have superpowers. So yeah, I see my, okay, perfect, thank you. So yes, as Stephanie mentioned, my name is Uri, and if you are fast readers, apart from the part I'm a Google developer expert, which means I try to push the web to its limit and see what it can do and then talk about it and blog about it. You probably also noticed that I work part-time for BlackBerry. Yes, they still exist. So basically, what we are going to talk about today is a technology I'm really passionate about. It's called Web Bluetooth. Before we get started with Web Bluetooth, let's get some things out of the way. So first thing first, I created a new Angular project. We are going to do some live coding. I'm just going to install a library that we'll use and start Webpack, because that usually takes some time, and we are short in time. So while Webpack is installing, I can tell you, first of all, this is my website, urish.org. If you have an Android device, I'm also broadcasting it using a protocol called the physical web. So if you have Bluetooth and the location open, you may see it in your notification list. Otherwise, you can go here. And one thing I want you to know, there is this Reactive Waves blog post that includes all the link and the information from this talk, so you don't have to copy the links, just check it out later. And today we are going to use, as I mentioned, there is a problem with my network. How unexpected. Let's try to see if this solves the problem. So we are going to talk today about a technology. No, I don't want MSN, but it probably means that this thing is not working. We are going to talk about a technology called Web Bluetooth, and we are going to use Web Bluetooth to connect our web page, our application, to a very interesting device. Before we do that, let me tell you a few words about Web Bluetooth. Basically, Web Bluetooth lets your web page interact with devices around it. There is a very comprehensive API. We are not going to dive into it today. Rather, we will see it working in practice, which is even more interesting, in my opinion. The one question I want to answer, because I always get asked that, is whether you can use Web Bluetooth today. And the answer is yes. Web Bluetooth works on Chrome, on Android, Mac, Linux, Windows with a polyfill, and soon there will be native Windows support. And shortly, we hope it will also work on iOS, so it will be available across all the platforms. And with that in mind, I see that our development server has started. Let's start see what we can do with Web Bluetooth. For that, I brought an interesting device. It's a commercial device called Muse, and it's basically a headset that allows you, once you put it on your head, it allows you to read the electrical activity on your scalp. I hope it works well with this headset. I haven't tried it at home, but wish us luck. The first thing we are going to do, we are going to use a small app that I created just to visualize the data coming from this headset, and then we are going to try to live code something with this. So I'm going to try to connect with it. Sometimes it needs some patience, so I hope it will work as soon as I hit pair. Let's see if it is on. It is on indeed. And this user interface, this dialog is actually a Web Bluetooth dialog asking the user to confirm that he wants to connect with the device. Let's try that. Device not found. Interesting. Yes, sometimes we need to do some troubleshooting. So I will open my Bluetooth devices and make sure that Windows can see the device. and then it will probably work better. Okay, so I can see it here, and I guess now it works better. Let's see if we get any graphs on the screen. 3, 2, 1. So much excitement. Let's do some drum rolls. Service not found. What an anticlimax. Another try. Another try. Yes, Windows, I know we can do it. We did it before. If it doesn't work, try to switch this thing off and on. And then if it doesn't work, we'll have to send you all to airplane mode. So you don't interfere with the Bluetooth here. Yes. Let's try this again. Well, it worked when I tried it at home. I'll try the scan devices one more time. That was add Bluetooth device. By the way, I heard April gave some good advice about meditation. Many people use this device for meditation. Let's try to see if it connects this time. Hopefully it will. Okay, are we ready to hit the pair button? It says connecting. There is still hope. Last time it didn't work. Maybe this time it will. So I'm going to try to restart the Bluetooth here. And see. So now you get a glimpse of what it is to do this in real life. Like, things are not always working as expected. But I'm still positive we can get it to work. Let's try it again. At least we got the Wi-Fi working. That's one thing. And let's see if now it finds the device. Maybe if I put it closer to the computer, this helps. Oh, yeah, this seems positive. Will it work? We did a drum roll once. Let's do it again. Oh, no, it doesn't work. At least I didn't get a blue screen. So we are going to try this one more time. I need you all to be very positive, to take all the positiveness that you can. So perhaps this time, device not found, but you show me the device. Why do you say it's not found? Okay, a lot of positiveness. Windows, you can do it. Otherwise, we'll have to send everybody down the airplane mode route. Connecting. Let's open the console. Oh, opening the console did the trick. Amazing. So yes, basically, I see there is, let's try to apply a filter so we see more data. So basically, I see there is some gap in the data. Maybe this is because the Bluetooth scanning is still running. And what I want you to notice, so this is basically the activity that is recorded from my brain. And let's just adjust it so we get a good reading. Or yeah, it seems to be well adjusted. Let me put it on. And now, when it's on, the noise should be gone, and you should be seeing my brain activity. Let's wait one more second for that to settle. Yes, so now it's actually reading my brain waves. Before, you have seen just noise. And what you can basically tell by looking at my brainwave that there is not much going on there. Yeah, that's the only conclusion. Another cool thing this device has is an accelerometer. So basically, it could visualize my head position. This is a WebGL object that I use to visualize. So when I do this, it nods like crazy. But what we are going to do today, basically, we are going to do the hello world of neuroscience. And that would be, let me show you what happens when I blink. So I'm going to be very still now, and now I'm going to blink. Have you seen the spike in the graph when I blink? I want you to notice the upper one and the one on the down, TP9 and TP10. These are the scientific signs. They basically mean left ear and right ear just for us developers. And whenever I blink, you can see spike, a negative spike, both on the left ear and the right ear. And the reason for that is that our eyes have a negative charge at the back, at the retina, and when I close my eyes, I move the eyeball, and this generates a voltage difference. So basically, that's what we are seeing in the graph. And what we are going to try to do, we are going to write a small Angular app that will detect those spikes when I blink and visualize them, do something according to them. So let's get started, finally, after we got the device to work. So we have this very basic app we just created with the CLI. And the first thing we are going to do, we are going to open code. I didn't do it correctly. We are going to open code, demos ngATL brain. How many code users do we have? Not too many, but it's very nice for live coding. So we are going to open our app component. And inside our app component, we have all of this boilerplate stuff. We are simply going to remove it and just say, hello, ngATL. And since we are doing some brain science, let's also put a brain emoji. Did you know we have an emoji for the brain? And we are going to add a connect button. And this button will basically call a connect method whenever we click on it. And next, we are going to implement that method. So we'll open our controller. And the first thing we need to do in order to connect with the Muse, we need to import the Muse client. Muse.js is a small library that I wrote that wraps the Web Bluetooth API to give you connectivity with this device, and it exports a Muse client class. So basically, what we are going to do, we are just going to create a new instance of it and implement the connect button. And the connect button is basically going to call this.muse.connect. And as you can see, this.muse.connect returns a promise. So we need to wait for this promise. This method opens the pop-up that asks the user to choose the device. And we are going to make connect async and await for this. Basically, await means wait for this promise and continue to the next line once it has been resolved. And after we have connected to the device, we are going to start recording the data. The start method also returns a promise, so we are going to wait for it. And now we'll adjust some console log so we'll know we are connected. And now the interesting part begins. First of all, it will be interesting to see if it will be easier to connect with it from our app. Hopefully, yes. We are going to subscribe to the EEG data. So EEG readings is an observable. How many of you worked with observables? OK, I'm at the right place. Perfect. And basically, we are going to subscribe to it and see what data we get by calling console.log. So first thing first, let's save this thing and save this thing. OK, it's happy now. And we got an Angular app with a brain and connect button. Let's disconnect this one so we can hopefully connect that one. I'm going to hit connect now. And let's have the console ready. No console, please. Yes, console. Yeah, OK. Let's hope it pairs this time. If all is well, we are going to see the word connected in the console, and then, this dreaded service not found. So what did we do last time to fix that? Do you remember? Oh, drum roll, right. And I'm going to restart the device again. Maybe it will help with the drum rolling. And if not, we are going just to cheat and skip this step. Muse, why are you so mean to me today? It's because I haven't had breakfast. I know. Anyway, so let's skip it. I will tell you what happens when we connect to it. We have this subscribe method, and basically this subscribe method will print out the data. And the data looks like this. We get from each item, we get the electrode index. The index, it doesn't matter, it's just the index of the sample, it's incrementing. And the interesting part is this samples array. It's an array of 12 values. These are the voltages that this electrode picked up from my brain at that moment. So every few milliseconds, I get this object with the electrode index and all the data that was picked up from my brain. And what we are basically going to do, we are going to use RxJS. What was that? We are going to use RxJS operators to process this data. So we are going to use pipables, as I like to call them. Some people call them letables. And the first thing we are going to do, we are only interested in the data from the left ear, the top graph that we have seen. So we are going to filter for that. I'm going to import some RxJS operators. Don't worry about that. And basically, the first thing we are going to do, we are just going to filter the data for the first electrode, the TP9. We have another helper object in the Muse.js library called channel names. So we will just use it to find the left ear is channel names, the index of TP9. And basically, we just want to filter all the samples, all the incoming objects that have their electrode equal to that electrode. So right now, we have incoming stream of data, and it's filtered only for the left ear. Next thing we want to do, so for each reading you have seen, we are getting 12 values. Let's put that one here. So we are getting 12 samples, and basically we want to detect the peaks in the graphs, where the graph cuts a certain line. So we are not interested in the individual samples. We can just take the maximum of each reading and see if it crosses the threshold. For that, we are going to take the samples and let's not call it data. Why it's not happy about that? Let's call it DT. Okay. And then we are going to take the samples, and we are going to find the maximum. We will use math.max for that. And as you probably know, math.max takes a few numbers and returns the maximum. But apparently, it doesn't like getting arrays. So we are going to solve that by using the spread operator for ES2000 something. And this basically just splits the array and passes each individual element as an argument to the function. And since some of the times the graph goes below and some it goes negative and positive, we are also going to be very positive today. It helped us before, and call math.abs. So everything gets positive, and then we found out the maximum. So at this point, we have a stream of values just from the left ear and just the maximum from each reading. And basically, we want to see if it cuts a certain line, so we are going to call filter again. Now we just have a value, and we want to see if this value is greater than some threshold. Let's define the threshold to be around 80 millivolts. I think that should cut. We'll figure out soon. And basically, at this point, we'll be getting only values that are above this threshold. So whenever I blink, the graph will go high, and this will generate the value. So next up would be to... Okay, so the next thing we will do would be to map this into truths and falses. Let me show you what I mean. First of all, let's do some switch map. How many of you are familiar with switch map? Okay, so basically what we are doing here, switch map is taking the value, it ignores it, and it emits true. So we are getting a true whenever there is a new incoming value that crosses the threshold. Then 300 milliseconds after that, we emit false. So whenever I blink, I will get true, and 300 milliseconds after that, I will get false. And then what switch map does, whenever there is a new value that crosses the threshold, it will simply discard the observable from the previous value. So if I get a value, I will get true, and then if I get another value within 300 milliseconds, I will get another true, and the false from the first one won't be emitted, only from the second one. So basically what I get here is I get the true, true, true whenever this crosses, and as soon as I stop crossing the graph and 300 milliseconds have passed, I will get false. So basically, at this time, we are having an observable that will emit true whenever I blink, and false 300 milliseconds after that. What we are going to do with that, we are going to save that as a property of our controller. Let's call it blinks, and it's observable of booleans. And we will visualize it in Angular, so this.blinks equals to this whole happiness. And what we are going to do with that, we are going to visualize it in our component. So let's create a new div and put there an eye emoji. And I'm going to give it a class of eye. And then whenever the user blinks, I'm going to give it a blink class, which will basically just look at the blinks observable and call async to grab the latest value from that. And let's set up those classes. So let's say for I will use a font size of 12 EM to make it big. And if it has a blink, let's make it red. So blinking is red. And now we basically, so that was all the UI code we had to create to visualize this thing. And now let's try to see if we can get it to work for the final time. So Muse, this is going to be your final chance. Please prove yourself worthy of being on my head. We are going to connect. If it has dash here, then it's most likely. Oh, thank you for the drum roll. Keep it coming. And I'm going to hit pair now. And maybe we'll see the word connected here in just 1 or 2 or 3 seconds. Drum roll, drum roll. Okay, one last time. If it doesn't work, you'll have to come to me afterward and try it yourself. And you will also have to be tested about how RxJS operators work. So, going to try this for one last final time. Yes, keep it coming, drum roll, drum roll. And I will do this Bluetooth thing to help Windows. Windows, I know you can do it. Add Bluetooth devices. This worked last time. Drum roll up, more drum roll. More Muse. I'm going to concentrate real hard and believe it will work. Touch it with the computer. Clap my hand 2 times. OK. And I am hitting the pair button. No. So come to me later, and you will see it in action. And I hope that you have learned 2 things. First of all, how RxJS is useful just outside of the web. And the second thing, the web can do amazing things, and it can connect to devices and read your brainwaves. I think that's amazing, at least when it works. Thank you.